Well, determining the proper chlorine dose is something that's essential if we're going to achieve the results that we're looking to achieve. And it's something we feel should take on a scientific approach. We do often see cases where the age-old approach of more is better is being used. But research has shown us that that's not always the case. And in fact, chlorine concentrations above about 500 parts per million can actually change the structure of the biofilm that they come in contact with and create a more dense, gummy, stubborn material that becomes more difficult to remove during the cleaning process. On the flip side, we also have a concern with undertreating the well, and we want to make sure that we have enough chemical present to do the job that we're asking it to do. So as a point of reference, we generally like to work within the range of 50 to 100 parts per million for new wells or wells that are showing a lower degree of fouling. And if we have an older well or a well that may have a higher degree of fouling present, we may up that range to 200 to 400 parts per million chlorine. So it's important that we stay within those ranges throughout the disinfection process for those reasons. Well, the short answer is no. Unfortunately, they can't all be treated the same. And we sometimes like to think that what worked well once will work well again. But unfortunately, wells just don't work that way, and our industry doesn't work that way. And that's because wells are simply not a one-size-fits-all entity. They vary greatly in their design, their construction, their age, the way that they're operated. And so our treatment strategies and our maintenance efforts have to reflect those variances. One big variable that we may see is the source water chemistry, which should be considered within the disinfection process. It's important that we know the pH and alkalinity levels within the water that's present and the water that we're using to disinfect with, so that we can manage the pH range within a 6.5 to 7 pH level so that we achieve the maximum cleaning efficiency of that chlorine solution. So source water chemistry is one variable that we want to look for. Another one may be the presence of other fouling mechanisms present within the well, whether it's corrosion processes that are taking place, mineral accumulations, the migration of formation influences and formation materials into the well, or a combination of multiple influences. We need to be aware of other fouling mechanisms that are going on. Because if we don't, those influences may affect the physical and chemical treatment strategies that we're employing to treat the well. And lastly, one other consideration may be is that biofilms don't always occur in the same location within a well or contain the same type or number of organisms. So it's important that we use the tools available to us, whether it's laboratory testing or a well video survey, to try to take a look at where the fouling may be occurring, where biofilms are growing, whether it's within the well itself or the surrounding gravel pack or further out into the formation, and then try to determine the degree of fouling that's there and what type of organisms we're working with. And so understanding those two aspects of the biofilms that are present will help us in customizing our treatment approach for each well that's needed work.